On this video, I'd like to talk about composition of trig functions. Let's start with the example. You have tangent of inverse tangent of pi over 3. So in order to solve this problem, what you got to do is you first need to evaluate what that is. Now remember, inverse tangent represents some theta such that tangent theta is pi over 3. Now, also you have to remember, inverse tangent has restriction. The answer has to be from negative pi over 2 to pi over 2. So, tangent of what is pi over 3? Well, that's not so obvious, is it? But if you remember, first of all, tangent is positive in the first quadrant and the third, but we have to ignore the third because of the restriction. So we have tangent theta. Here's the theta. Definition of tangent is y over x. So what is your y? Pi. What is your x? 3. So that is tangent theta equals pi over 3. Now let's go back over here. That is a theta. Now this theta right here is same thing as this theta over here. So what is tangent theta? Well, it's pi over 3. Our final answer will be pi over 3. Let's take a look at another example. You have inverse cosine of 3 pi over 4. Now, you first need to evaluate what cosine of 3 pi over 4 is. Well, those of you who don't like to work with radian, 3 pi over 4 is same thing as 135 degree. So what is cosine of 135 degree? Well, let's look at the reference angle. The reference angle will be 45. So the angle, theta, angle is in second quadrant. And what is cosine of 45? Well, cosine of 45 is radical 2 over 2. But cosine in second quadrant has to be negative. Therefore, cosine of 135 is negative radical 2 over 2. So we're looking for inverse cosine of negative radical 2 over 2. This whole thing now represents some theta. Cosine of what will be negative radical 2 over 2? Well, remember, inverse cosine has restriction. You have to go from 0 to pi. Whatever the answer you get, the answer has to be from 0 to pi, including the endpoints. So cosine of what is negative radical 2 over 2? Well, that's when theta is 135, or 3 pi over 4. So the answer is 3 pi over 4. Let's take a look at the example. By now, if you based on your conclusion based on last two examples, you might want to cancel out the arcsine and sine. Therefore, you might think that the answer is 2 pi over 3. But it's not. It's not 2 pi over 3. And here's why. Let's first evaluate sine of 2 pi over 3. Again, those of you who like to work with the degree, will be sine of 120 degree. And what is sine of 120? Well, that's in second quadrant. Reference angle is 60. And sine of 60 is radical 3 over 2. Sine in second quadrant will be positive, so it is radical 3 over 2. So basically, we're looking for arc sine of radical 3 over 2. Now, remember, again, this whole thing represents theta. And arcsine theta has a restriction. It goes from negative pi over 2 to pi over 2. It only goes from fourth to first quadrant. So we're looking for sine of what will equal to radical 3 over 2. Well, sine, you know that sine is positive first and second, but since we have a restriction on our sine, we have to look at the first quadrant. So what is theta? Theta has to be sine of pi over 3 is radical 3 over 2. Therefore, the theta is pi over 2. So therefore, answer is pi over 3, not 2 pi over 3. Let's take a look at this example. We have inverse cosine of sine of pi over 3. So what is sine of pi over 3? It's going to be radical 3 over 2. So basically, we're looking for inverse cosine of radical 3 over 2. So what are we looking at? Cosine of what theta will be radical 3 over 2? Well, the theta is pi over 6. Again, you have to think about the restriction when you talk about inverse cosine, which goes from 0 to pi, and pi over 6 is within that restriction. Therefore, the answer to that problem is pi over 6. Let's take a look at this example. You have sine of arctangent of 5 over 12. This represents some theta. So we're looking for tangent of theta is 5 over 12. Again, arctangent is a restriction. It goes from negative pi over 2 to pi over 2, not including the endpoints. Tangent theta equals 5 over 12 is not that obvious. But if you draw a triangle, since tangent is positive, it has to be in the first quadrant. And tangent is opposite, the y over x, so 5 over 12. Now, if this is a right triangle, so if this is 5 and that's 12, what will be the hypotenuse? Using your Pythagorean theorem, you're going to get 13. So, what is sine of theta now? Since that's theta right here, sine of theta is y over r, which is 5 over 13. Therefore, the final answer is 5 over 13. Let's take a look at sine of r cosine x. This represents theta again. So we're looking for cosine of theta is x. Restriction on r cosine is 0 to pi. And since cosine is positive, we're talking about an angle that is in first quadrant. And what's the definition of cosine theta? Well, it's adjacent over hypotenuse, or it's going to be x. If you write x as a fraction, it'll be x over 1. So adjacent becomes x, hypotenuse becomes 1. Now, how do you find this value right here, y? Well, if you use a Pythagorean theorem, it's going to be 1 squared equals x squared plus y squared, which is 1 minus x squared equals y squared. and our y is positive negative radical 1 minus x squared. So that becomes, now you have positive and negative. Y is positive when it's above the x-axis. It's negative when it's below the x-axis. So this is going to be radical 1 minus x squared. That's our y. So what is our sine theta then? Our sine theta is going to be y, which in this case, radical 1 minus x squared. So it's going to be radical 1 minus x squared over r, which is 1, which is the same thing as radical 1 minus x squared. And that's our final answer. Let's take a look at our last example. You have cotangent of inverse sine of x. So this, again, that represents a theta. So sine theta is x. If you change x to a fraction, you get x over 1. Restriction on inverse sine is negative pi over 2 to pi over 2. Since sine is positive, we're looking for this triangle right here. So opposite is x. Our hypotenuse is 1. So what is this value right here then? Well, using Pythagorean theorem, you're going to get radical 1 minus x squared. So what is cotangent theta then? Well, look at the triangle. Cotangent theta will be adjacent over opposite. So radical 1 minus x squared all over x. So our final answer is radical 1 minus x squared all over x. That is your final answer.